Good evening. So I'm going to pick up with 5.7. I started this actually last time and then realized it was for this week's material. So we'll go over it a little bit more again. 5.7 is on factoring. It's just a review. And so I have basically when you're doing factoring, you want to think about if there's a common factor, a GCF. And then from there, think about how many terms it has, because how many terms dictates the way you can factor. So if it has two terms, if you can factor it if it's a difference of squares. So if you have something squared minus something else that's squared, figure out what's been squared, have a plus between one set and a minus between the other, so that when you FOIL, when you multiply these out, the middle terms cancel. The negative AB and the positive AB would cancel, leaving you just with the A squared and the minus B squared. The difference of squares. Similarly, we have sum and difference of cubes have formulas. These you can't come up with them quite as easily, so this is worth memorizing because there's no way around those formulas other than memorizing them. You can verify they work, but you need to memorize them to be able to put it into factored form. Or it could be that there is no way to factor it at that point. When there's three terms, we're going to be dealing mainly with quadratics, not exclusively, but mainly quadratics. And when the leading coefficient, the A, is 1, we can see what multiplies to that C value and adds to your B. So in other words, if I had something like, if I had something like m squared plus 7m plus 10, I could say, well, what multiplies to 10 and adds to 7? And so that would be 5 and 2. So it needs to multiply the 10 because of the L part of FOIL. It needs to add to 7 because of the O and I of FOIL. And then, of course, your F of FOIL is why there's the m's there for the m squared. When your A is greater than 1, when your leading coefficient is greater than 1, then you need to account for that. These two things can't just be your m's, because that wouldn't get you any other number other than 1m. So you need to account for how that plays into your O and your I of FOIL. And so you have to do your A times your C. So I use this X to organize my work. It's your A times your C. I think of it as attic and ceiling towards the top, and that's why I multiply to. And the B goes towards the bottom or the basement, and that's what you're adding to. And you figure out what pair of numbers works for that. And that's how you're going to split up your middle term in such a way then that it is factorable by grouping. If A is less than 1, then you factor out a negative and you can apply one of those rules. And then there's special cases which you can again do as though the A is 1 or not, depending on what your leading coefficient is. But this is a quick thing if you recognize that it is a perfect square, that you can factor it in a quicker way. And I'll show you an example of that. And then, of course, if it's 3 terms, it can also be that it's prime. If it's not quadratic like this, then you might be able to make it quadratic. It's called quadratic in form or U substitution. Or you might be able to make it represented in this format. Lastly, in this course, we do things with 4 terms, and we do that by the grouping method, which is where you cut it in half, factor each half. Generally, putting it in standard form is a good idea. Cut it in half, factor each half. If you factor it completely and there is a common factor, you can factor out the common factor and then have your leftovers. And if it cannot be done that way, then you'll learn how to do those in pre-calculus. But you won't be dealing with that in this course. So here are a couple of examples. Wanted to just mention some of the more challenging ones and just ones to pay attention to. For example, this has 4 terms, but cutting it in half, you can factor out x, and you'd have x minus 8, and here you could technically do a difference of squares, but you wouldn't have a common factor. So this one is actually a difference of squares once you recognize that that is a perfect square of x minus 4. And if you don't recognize that it's a perfect square, then you say to yourself, what multiplies to 16 adds to negative 8? And you realize that it's x minus 4 and x minus 4. Let me see if I can't get the light to be a little bit better situated. And then you can treat it as a difference of squares. So x minus 4 plus y, and then x minus 4 minus y, and those are all unlike terms, so that'd be as far as you can go. Here's another one that's not quite meeting the traditional pattern. This is to the 4th power, but you have 2 options of thinking about this. One is to recognize then that your final answer will be something x squared and something x squared, so that you get x to the 4th, and that you have an x squared term and an x squared term for your O and I of FOIL. And so we can treat it as though it's just the x's, what multiplies to negative 15 and adds to negative 14. And then do grouping, because your A was not 1. Minus 15x squared plus 1x squared minus 5. Cut it in half, factor out. Oops, I didn't take a 3. Take a 3 out. Take out a 1 there. Common part, and then the leftovers. So we've got 3x squared plus 1, and we have 1x squared minus 5. Alternatively, you can say let u be the x squared, and you can turn this into this kind of example. And then you could solve it, and you'd end up with 3u plus 1 u minus 5, and then you can replace the u with the x squared. Same answer, and that method is called u substitution. Here's another difference, and these are perfect squares, so it might look scary that you're having a fraction, and I wouldn't recommend, saying what multiplies to negative 4/9 and adds to 0 if you're not loving fractions. But if you recognize it's a difference of squares, take the square root. One has a plus, the other one will have a minus. Take the square root. So square root of 4 is 2, square root of 9 is 3, and there you go. Similarly, this is a difference of squares. This happens to be a perfect square trinomial, and the way I know that is that this is a perfect square. This is a perfect square, 4/5 y, and this was just x. And this middle term does meet the requirement for it to be 2 times the x and the 4/5 y. So it does meet the a squared plus or minus 2ab plus b squared. The plus would be if it's a positive with your perfect square, and a minus if it was a negative for your perfect square. So this factors to a, because it's a minus, minus, if it was a plus, it'd be a plus, b squared. So we're going to go ahead and, in this case, again, positive with a positive, negative with a negative, we're going to be using the negative. What was squared was x. What was squared was 4/5 y. Number 5 over here has a common factor. Again, that's always where you want to start when you're doing these. It has a common factor of 2x cubed, leaving me with 8x squared minus 22x plus 15. So then I want to see if that trinomial can be further factored. So I think what multiplies to 8 times 15, so what multiplies to 120? Your A times your C, that's A, B, C. And what adds to your B, again, A, B, C, because it's in standard form, negative 22. And you might have to play around with a couple options. I mean, we did 8 and 15, so that's an option. I could take half and I could double. And I could even take half of that and double that, but I'm getting further away. I'm making things worse. So it is closer to 4. It ends in a 0, so I could try maybe 5 times something. So 5 times 24, that's dividing by 6 and then multiplying by 6 essentially from that. We could do times 2 and then half. And there it is. If these are both negative, they will multiply to a positive and they will add to the negative 22. And then I'll do the grouping. So 8x cubed minus 10x minus 12x plus 15. Cut it in half, factor. When you factor out a negative here and a 3, a negative times a negative would get you that positive. And now those do match up. And then there's your leftovers. So we factored out the 4x minus 5, and then that's what's left. So here's the 4x minus 5 times 2x, and here's the 4x minus 5 times the negative 3. So your final answer looks like this. Don't forget about your initial greatest common factor you took out, so that when you multiply these all back, you do get your original problem. Let's do another one with 2 terms, and this one, it's a little bit like, I don't even see a sum or there's no difference of cubes. Sorry, there's no difference of squares, but there's a sum and difference of cubes, and this does look like it has some cubed stuff and a plus, so maybe it meets that. Let's take a look. Factor out GCF 5 and a y. And now it's a little more obvious that this is x being cubed, and this is 2m being cubed. 2 being cubed gives you 8, the m being cubed gives you the m cubed. So I can apply the rule, which I'll put over here. If it's a plus a cubed plus b cubed, a sum of cubes, the rule for that is a plus b times a squared minus ab plus b squared. And so in this case, we are going to have our a is, as I had here, the x. It's what was cubed, so x, plus our b, which was what was cubed here, so 2m. Then I'm going to square the a, so I'm going to have x being squared, minus my a times my b, so 2xm. And then plus my b squared. Now when I square this, I'm squaring the 2 and the m. I'm squaring that quantity, so it's 4m squared. And so last but not least, we put the 5y. In fact, I'll just squeeze it in right there. This next one, GCF again, always think about that first. And even though it might look like it's a cube thing because of the 8m cubed, that's not a perfect cube. So it isn't a difference of cubes. And additionally, it's a good idea to factor out your GCF anyways. Now this is a difference of squares, 2 terms. They're squares, and there's a minus. So square root, 1 has a plus, 1 has a minus, so the middle term, the m term, would cancel out. You have 0 m's. So we did end up doing a factor by grouping here and up here. So I'm not going to do this top one up here, which was factor by grouping as well. So I hope that helps. I'm going to pause for a moment, and then we'll pick up on 5.8.